beim Track 1, Netzwerk und Cloud Security. Wir haben heute sehr spannende Vorträge für Sie. Mein Name ist Stateless Tokenization und ich werde Sie heute hier begleiten. Ich hoffe, dass Sie am Ende des Tages vielleicht irgendwelche Antworten finden, vielleicht auch Sie Fragen stellen, aber auf jeden Fall viele wertvolle Informationen mitnehmen können. Unser erster Vortrag befasst sich mit dem Thema Datenschutz und der Fokus liegt auf Datenverschlüsselung. Wir kennen alle, wie kompliziert die PKI ist und dass die symmetrisch-asymmetrische verschlüsselte Kommunikation auch Probleme hat. Was sind denn die neuen Methoden in dem Bereich und wie könnte zum Beispiel so ein Internet of Things Objekt mit einer Legacy-Anwendung, mit einer Anwendung und zum Beispiel auch mit der Cloud kommunizieren? Das und auch noch viel mehr erzählt uns Daniel Clift von PACKARD Enterprise. Daniel, welcome, and now the stage is yours.
Thank you. Is the microphone working? You okay? Is that better? Okay. So, good morning everyone. I hope you're all here to hear about data-centric security, because that's what I'm going to talk about. I'm thrilled to be here to present to you all, to be part of this to be thrilled to be part of this IT Cube event and to represent HEWLETT Enterprises and hopefully tell you something that you don't know or share some stories with you. When I read the description of my speech, my talk that was put together by ITQ, it reminded me very much of a film. Because this show has a theme, I created this slide, which I just want to play for you. The theme obviously being the future, and this is kind of representative of the future. Obviously the German version is much better, but I don't speak German, so I apologise for that. So, let me tell you about myself. So I don't come from a traditional security background. My background is credit cards and payments, and I started in that industry back in the year 2000, so 16 years ago. And when I first joined, I was amazed with the carelessness that people treated that sensitive information. On one hand, you had all of these reports of credit card fraud, and on the other hand, I could go to any network share that support used and get tens, if not hundreds of thousands of credit card pieces of data, including the 3 digits on the signature strip, the CSC. So this led me to kind of start investigating IT security, cryptography, and other ways to protect that information. And then eventually that led me to join a small California startup called Voltage Security, and that company was purchased by HEWLETT Enterprises back in April of last year. Also my story, I have 2 cats. I run 5 and 10 kilometres quite slowly, and I'm a keen baker, so I like to bake my own bread. And if you want to come and talk to me about those things, that's much more interesting than this stuff. This is a new presentation, so I haven't given it before, so I may run over, I may run under. I apologise if I stumble over my words a little bit. So the theme of the show was aerospace, robotics and the future. And I was scratching my head and I thought, I love aerospace, it's awesome, but I don't really know anything about it. And robots are really cool, but again, I don't really know anything about robots, and who knows what the future's going to hold. I don't know. So what can I talk to you about? What will fit in with this theme of the show? So I thought, well, cryptography is kind of futuristic, and I know a little bit about big data. I've got customers who use robots, so maybe I can talk to you about those things. So that's essentially what I'm going to do. I'm going to tell you some stories from my customers. Before I do that though, let's talk about Nissan. Everyone knows Nissan, big car manufacturer. Recently they had to pull their mobile application and mobile services from their connected car because they found that anyone can control anyone's car as long as they know the VIN, the vehicle identification number, with no authentication, no security. That's how they released the product. So let that sink in, no authentication, and they put that to the market. I find that pretty gobsmacking. So let's look at another story. So this is a story about Elon Musk and the Tesla Corporation. They had a review that was written by the New York Times. This is a very well-known story, so if you want to Google it, you obviously can. The reviewer is a gentleman named John Gruder, and he found the car significantly lacking. He gave it a really bad review. It didn't charge properly, it didn't do the distance they said it would do, it didn't work in cold weather, it was a really negative review. It didn't even make the shortest trip to New York, which was the kind of the premise of the story. This, as you can imagine, didn't go down well with Elon Musk. So him and the Tesla Corporation, they hit back. They hit back on television, they hit back in the media, and they hit back on social networking like Twitter. They essentially, the story is that the data logging of the car was turned on, and they have done this for every car that is put for review since the episode of Top Gear, where they showed the car being pushed because it run out of electricity. So the car is logging everything. And they pointed to the data in a very public way and said that John Gruder's review was fraudulent, and that he had written it for a very specific reason. And they didn't go as far as to say, but essentially implied that he was writing it on the behest of the classic automobile industry. Essentially, the story goes that he didn't charge the car properly, he didn't drive it properly, and even as he got closer to New York, he decided to pull into a car park and just do loops of the car park, trying to wind down the battery before he got to his destination, so he could write the story he wanted to. So why am I telling you these stories? These aren't really connected with security, and they're not really connected with the future. So to answer that, let me tell you another story, because stories are great, everyone loves stories. So this story is about a customer of Voltage Security, now HEWLETT-PACKARD Enterprises. It is a global car manufacturer. It is not Tesla. It is not Nissan, and it's not Lotus. I just really like that picture. But it's one of the other ones, and it is a very large company. Next slide. So cars have been pretty much the same since their inception. They've had four wheels, they've had a steering wheel, they've had an internal combustion engine. They haven't really changed in their entire life cycle. And then if you look back maybe 10 years when the first hybrid cars started to come onto the market, and you look at where cars are going now, you know that everything is in a state of flux, and the car manufacturers are having to move fast, because with this industry where everything is up for grabs, they could essentially lose their market share. We are going to have cleaner cars, we're going to have electric cars, we're going to have fuel cells, we're going to have home charging. We are going to have people talking about autonomous cars. And autonomous cars can obviously lead to people not buying cars but leasing cars. And this is a frightening concept for a car manufacturer. So if you think about it now, you go out, you choose a car that you like, you rely on the badge to tell you about the reliability of the car, You may take on a 2-year lease or a hire purchase for the car, but essentially you're buying that car as a personal shopper. In the future, that's not how it's going to be. If you live in a city now, you may already do this. You may hire a car for a couple of hours or a couple of days through people like Zipcar or blah blah car. When, not if, but when autonomous self-driving cars come, you will be able to lease cars by the hour, by the day. They will come to your front door, you will pay for the time that you use them, and this is the future that companies like CLIFT and Uber are getting ready for. So being the massive fleet management organisations that can just manage cars. Will you care that the car that comes to your door is a BMW or a Volkswagen? Don't think you will, as long as the car is there when you want it to be and it's clean and takes you where you want to go without any accidents. Doesn't matter what sort of car it is. So this is kind of terrifying for car manufacturers, and it changes their market fundamentally. So to use an analogy, it becomes a lot more like planes and trains. If they are not working, they are not earning money. If a plane is on the ground, it's not carrying passengers, then it's not being productive. And cars are going to be that way if this autonomous revolution comes off. To be able to have a fleet of cars that are maximising their revenue potential, then car manufacturers are going to have to be much more in the space of predictive maintenance, allowing them to maximise that revenue, the on-the-road times for that car. And that leads to them having to know a lot more about the car, the way it's driven, the conditions, the weather, the number of hours of service, which parts are being fitted to that car. The more information they can have, the more ability they have to predictably maintain those cars, keep them on the road, maximise that revenue. The greater the reliability, the better the service, and the better the maintenance they can perform as manufacturers and dealers and garages, the more chance they have of selling their cars to these new organisations like CLIFT and Uber. So how are they going to get from where they are now, in an industry that is 100 and something years old, to where they need to go in the future? And that is by investing in technology, including the Internet of Things and big data. So let's define some terminology here. I'm not going to read this for you. You guys can read this, but just so that we're all on the same page, the Internet of Things is somehow a device that has sensors that is connected to the Internet and reporting data back to some central place. And usually there's a control loop that allows that central place to send data back to the device to change its behaviour, make it do different things. And the big data definition, again, I'm not going to read it for you, but it's there. Wikipedia is very trustworthy. It's not like anyone can go and edit these definitions. But again, they often go hand in hand. You have the devices, the data, and then some form of analytics happening. And where do these Internet of Things come into your lives? They are literally everywhere. They aren't just in your cars, they're in your phones, they're in your new smartwatches, they're in your thermostats, your security cameras. There are some really crazy examples. Everyone tries and talks about the smart fridge. Samsung loves this concept of a fridge that will order you milk and run out of milk. I think that's a little bit crazy. But it can be literally anywhere. I've seen tennis rackets with sensors in them, so when you're striking the ball, it knows if you're doing the right topspin or the right backspin. They literally can be any device now. People are using this as a way to differentiate their devices from the competitors. And then some examples of big data in your life. And some of them are benign, like image recognition. You go onto Google for image search and you search for pictures of dogs. It's not a human picking out all those pictures of dogs. It's a machine with AI learning, going, this is what I think a dog looks like, and then going through all of the pictures and going, that's a dog, that's not a dog, that's a dog, that's a cat, it might be a dog, I'll put it in the dog pile. And it goes from the benign things like advertising and image recognition right through to some scary things like DNA sequencing and insurance underwriting and all of those things which are essential but have problems when it comes to the type of data that they are analysing and using for that big data lake and those analytics. So, back to my car manufacturer. Now that we know what IoT is and we know what big data is. So my car manufacturer has a lovely, great big data lake, and they're running some analytics tools, and they are collecting data from the dealers when you buy the car. So they know who's bought the car. They have the data from the cars, and this isn't just tiny bits of data from cars. This is essentially everything. They know which pistons are firing, they know how hard you're pushing on the brake, they know that you listen to this radio station, that you drive aggressively, that you're right up against the car in front. They know literally everything about how you're driving this car. They know how fast you're going, obviously, and they know your location, so they know where you are, because all nice cars have GPSs built into them. They also have mobile apps. So think back to my Nissan story. There are mobile devices that can connect to these cars and cause actions to happen. And they may be as benign as turn on the heating 10 minutes before I come out of the house to get in the car to go to work, but they can be things like starting the car with a mobile app. So you want to have some degree of security around that. And obviously we're feeding in data from third-party sources as well. So traffic data, you want to pull in traffic data, you want to push it to the cars, so that you can route people around traffic jams. When it's snowing and all the roads are clogged up, you can facilitate people moving around much more without impedance. They know when you fill the car up with petrol, or when you plug it into the power. They know how long to charge it for, whether your petrol consumption rate is what it should be. And they know whenever you take it to the garage, because the first thing they do when you take it to the garage is you plug it into a computer. So you can really think of these cars as computers and sensors on wheels. That's what they're slowly morphing into. And then most importantly, we have this arrow that's going in the opposite direction, and that is our feedback loop. So data fed into the analytics platform, into the big data lake, but also data pushed back out to the car. So we have a lot of data flying around here, and a lot of value in that data. So what do they know? Well, essentially they know everything. They know who you are, who's driving the car, they know the VIN, they know the location, they know how fast you're going, they know if you're speeding, they know if you've got passengers, because obviously seats now know if there's someone sitting in the next, they'll want to put the seatbelt on. They know how often you service your car, how often you fill it up. They know literally everything. So, in security, we have an old adage that the more you know about someone, the more valuable that data is. So, okay, so I know the VIN of your car. Does that really give me anything? No. But if I know it's you, and this is the VIN, and this is where you live, this is where you park at night, these are the shots you shot at, it becomes much more valuable, that data. So does the fact that all of this data is flying around, does this really matter? Let me kind of talk about a couple of reasons why I think it does. So there are confirmed cases of car manufacturers refusing warranty claims because they have looked at the data and they have seen people have taken their cars to the racetrack and driven them quite hard, and then taken them home, taken them to the dealer and said, the gearbox is feeling a little bit funny. They've looked at it, they've gone, no, we're not fixing that on warranty. So that's a reason why it may affect a person. There are also reasons why it could be important to an organisation to think about protecting this data. So there's a gentleman in the US called James Clapper. He is the US Director of National Intelligence. I'm going to read this because it's important I use the right word. He said recently, in the future, the intelligence service might use the Internet of Things for identification, surveillance, monitoring, location tracking, targeting for recruitment, or to gain access to networks or user credentials. So, I'm not here to be a bogeyman and talk about Edward Snowden, we need to protect all our data. But people see value in this data and in these connected devices. Organisations see value in using the data to differentiate their organisation from other competitors. And intelligence services see value in using these devices and these data. So you need to think about how you're going to protect this data. So back to my customer, the global car manufacturer. They protect this data with a technology called format-preserving encryption. This is a, let me build the slide. This is a mode of the AES algorithm. So in the same way as you have the CBC modes and the ECB modes of AES, this is known as the FFX, so Freddy X-ray. It is an encryption technology that is part of the AES family. So it inherits all of the cryptographic strength of AES, but it allows us to be very particular about how our protected values look. So we can subset data, we can make sure that data is length preserved, so names and addresses stay as names and addresses, numerics stay as numerics, and we can be super clever about things like dates of birth, so that a date of birth will encrypt to a real valid date. So the idea is that an organisation can define the format, in format preserving encryption, they can define the format for their data and keep it protected throughout their organisation. They can keep it protected when they're doing analytics on it, and the reason we can do that is we preserve the referential integrity. So if they protect the same VIN in two different systems, it will protect the same value. So joins, unions, primary keys all continue to work with protected data. It's important to understand that they don't use this on all data, they use this purely on the data that matters. So if I can't identify the person, the address, the vehicle identifying number, does it matter that I know where they go, which shops they visit, where they fill up with petrol? Maybe it does, maybe it doesn't, but they select the fields. We're not encrypting and protecting all the data, we're just protecting the sensitive fields that they deem important. Because this is encryption, it's reversible. So if I'm given the key, I can decrypt back to the clear text data when you need to show it to a user on a screen, when you need to print it on a report. But the idea, and this is what they do, protect as they receive the data, and deprotect as late as possible, and then everything in the middle just operates on protected data. Now, I'm not saying they then get rid of all their other security solutions, so they've still got VPNs, they've still got encrypted disks, they've still got Oracle TDE, but the data itself remains protected as well as all those outer layers. So you can think of it like an onion. Protect the data, protect the perimeter, protect the systems, and it has multiple layers of protection that someone then needs to breach to get back to the real data. So, what do they actually do? So, they have data coming in from cars over here on the left-hand side. They haven't rolled this out to all geographies and all cars that they manufacture, but they are already processing 2 billion real-time transactions a day. So that is all sorts of events, and it's not all events from the car, but all sorts of events coming in into a system that's up here that you can see we've got the Flume logo on. So Flume is a part of the big data, the Hadoop infrastructure. It's for log management. So they're receiving log data and in real time identifying the fields that are sensitive and protecting them, and then passing that back into their Hadoop clusters. They also have feeds coming from other data sources, from dealerships, from manufacturing facilities about the different parts that are fitted. And then again, that is protected on ingestion, this time using a technology called Scoop. And Scoop is another Hadoop technology that allows them to pull data out of a relational database. So they can select tables from a relational database, protect as they're reading the data, and write it protected to HDFS. So in both these cases, the data, by the time it gets into Hadoop, is already protected. So protecting as early as possible and using the data protected. And then they have lots of other things going on that we can talk about. They have MapReduce jobs running on protecting other pieces of data, but also on identifying data for users who are privileged. So if they need to get back to the clear text data, they can do that natively within a MapReduce Hadoop job. And then they export protected data to Teradata. I love if that was HPE's Vertica, but unfortunately it's Teradata. But again, we can de-identify data or access data when we need to in those systems. And you'll also see Cosmos and DataStage there. So the benefit to this manufacturer is that they have essentially better customer satisfaction today. They are able to offer new services like predictive maintenance. So they can, when you buy a new car, they can say to you, you may have experienced this, they can say to you, if you give us X number of euros per month, because they know the cost the maintenance will be, we will cover all your tyres, we will cover all your brake pads, we will, whatever car manufacturers want to sell you, but they want to sell additional services and they can cost those in knowing how reliable their cars are. And because they're taking data from cars, from garages, and also from the manufacturing process, it allows them to be much more precise about part defects. So if they know that all the parts from this factory have been failing, or a significant proportion of them, they can go and look at the quality of that factory. If they know that all the parts fitted by Bob have had to be fixed, but all the parts fitted by John don't, then they can go and have a look at how Bob is doing those operations. They can really drill down into this data because they have it from all parts of the car's life cycle. And most importantly, it allows them to get ahead of the competition and the disruption in their industry they see coming in terms of self-driving cars. So they are enabling business opportunities now, they are adopting new technology and getting experience in them for the competition they see coming in the future. So all of this is done with a HEWLETT-PACKARD enterprise product called Secure Data. It offers data-centric, persistent data protection, and those words are very important, and I use them a lot. We protect data. We don't protect sandboxes, we don't protect disks, we don't protect volumes, we don't protect the network, we protect the data itself, and we keep it usable. And it's persistent through an organization's infrastructure. We use standards-based AES, the FFX mode. So there is nothing here that is There's nothing here that is closed off or unexplainable. Everything is peer-reviewed, everything is cryptanalysis, everything is open to world-renowned cryptographers to look at and use on. And we welcome our customers asking us really deep, low-level crypto questions. Because it's part of the AES standard, it's also licensable to other security vendors. So anyone can go to NIST and license this technology. So there's nothing here that is locking you into my product set. As I said, everything we do is open. There is no security through obscurity in the way that we operate, and that comes from our foundations as a spin-out of Stanford University. So academia and openness is in our DNA. It implements a central policy to define how data is protected. And we haven't touched on this, but if you can minimize the number of points where you define these policies, the chances for erroneous configuration are minimized. And the fact that we have stateless key management means that you just don't have all of these keys to manage. We can have 1 million cars all submitting data. It doesn't make the scalability of this solution any harder. And it's heterogeneous. So I protect data, and I don't mind if you store it in a database, in a flat file. I don't mind if you use ab initio's ETL or Informatica's ETL. I don't mind which Hadoop distribution you use. I want to protect data and make it work in your organization, in your infrastructure. And we do that through web services and APIs on pretty much every platform. So I can encrypt on a mobile device, and I can decrypt on a mainframe, and everything in between, and it's all interoperable. So let's go on. So I've probably gone a bit quicker than I was going to go, so there's lots of time for questions. If you guys have any, if you want to know more about how they do what they do, or why they chose us, or anything else about the voltage technology, then please go ahead.
Hat jemand eine Frage?
The car manufacturer. The manufacturer. Was it an European one or an American one?
It was an American one. Well, it was an American one, but it is global, so it has operations around the world.
Okay.
I would love to tell you who it is, but I can't. I really would.
I think so.
One of the biggest three in the world. No, shorten it, no.
Noch eine Frage?
What are typical scenarios to use that technology? So we've seen the Hadoop integration. What others are?
So that's a really good question. So the things to bear in mind is we can leverage this technology wherever someone sees a risk in their data being exposed. So this was all about Hadoop. And people want to move to big data because it gives them something that they didn't previously have, or something that was very expensive in terms of Teradata. Now, as Hadoop is an open source project of moving at 1 million miles an hour, it's trying to catch up with those data warehouses, but security is not on their roadmap. So that's why, in this case, format preserving encryption became a really nice way to layer on that security to this technology. We see the same concerns and the same use cases with cloud adoption. So I've got customers who will take their data, protect it, put it in Amazon Web Services, put it in EC2, put it in Azure. Because they hold the keys, they protect the data, they don't care where it's stored. To a degree, they don't care where it's stored. I've also seen customers use the technology to take production data and mask it or anonymize it and give it to development for test and integration testing. And then the fourth key use case is in terms of geographical data residency laws. So different countries in the European Union have different rules, and you may find that Germany is quite strict, but Luxembourg is really strict, and Switzerland is super strict about data leaving their geographies. So I've got customers who will protect data in country, and then analyze it and use it in their HQ offices, in their own systems, and then only re-identify it back in country. So they can achieve that geographical separation in terms of compliance with the local legislation, but still allow them to use the data in its whole across their entire organisation.
So you're encrypting the data, and the analysis is done on encrypted or pseudonymized data, right?
Wherever possible, yeah.
Okay, but you're losing information. Let's say you have a zip code. If you apply your encryption, then you have a different zip code. And if you do some big data analysis, where are the best drivers? Are they in zip code 11111 or in 9999?
Yeah.
Then you have a different idea. So how do you, and you can put this example on different things like birth date, for instance. If you look at generations, well, I'm 45, if you encrypt me, then I'm 60.
Yeah, so you need to, it's a really good question because it's like the next thing that you have to think about. The key, not the key, the core thing, I say key a lot, talking about crypto. The core thing to think about is you've got to know your data, and you've got to know how you're using it. So your zip code example, I don't know if it's the same in Germany, but in the UK, as you get more and more digits, it becomes more and more accurate. So if you're looking for a general understanding of which area the best drivers are, maybe you only encrypt the final 3 digits of postcode or the zip code. So you can still see that they're all in Munich, but all those drivers in Berlin are terrible drivers. If you think about wanting to know someone's height, I do a lot of work with medical organisations and they want to know someone's height, then we can create ways of protecting the data so that people remain within certain ranges of heights. So someone who is 5 foot something will still be 5 foot something. So you've got to think about the data and protect it in a way that still allows those analytics, or you deprotect it for those reports, those small pieces of analytics. So that is one of the cases where you ring-fence that data, you lock it away, you only give access to you because you're trustworthy and you're doing this report and you need the clear text data. But it's an excellent question because we can protect everything, but is it still usable? So we're trying to strike, security is all about striking that balance between security and usability.
Daniel, maybe I have one question. From your experience, what are other use cases that you have implemented, and what was the implementation effort in terms of time and maybe manpower?
So I think I answered that question over there, but the implementation time is one of those questions where all good questions start with an answer that says it depends. So if someone knows their systems and has a defined data set that they want to protect and they know the flow of that data through those systems, then the implementation can be quite quick. If you have to do a data discovery phase or check with legal to make sure that it will address your regulatory and compliance issues, then those projects can take a lot more time. But the actual time for my technology to protect data, it's very small. The project could be a lot bigger, depending on what you're trying to protect and how you're trying to use it. So I have one customer which is a telco, in a global telco. They use it to protect 27 data types in all of their applications. So they bought it as a simple service, and then they went out to their business units and they say, if you hold credit card data, if you hold medical data, if you hold HIPAA, high-tech, SOX data, whatever it may be, then you need to protect it, and I've got the technology. So in that case, the project isn't really with me as a technology vendor, the project is with the different business units coming to these subject matter experts in their central security division and implementing that protection for their systems and their business unit. And they're currently looking at a project of about 500 applications throughout their entire organisation, and they're rolling out about 50 or 60 a month, something like that.
On what layer are you implementing your solution? On the database layer or on the application layer?
On the yeah, sorry, I should have covered that. On the application layer. So if we can protect data as high as possible, we get protection for all the layers underneath. So if we were just at the database layer, then if you come and write a select statement to the database, the data comes out in clear. So if we can move up, then you protect everything underneath. You protect the network, you protect the database and the volume with one technology. Now for some implementations that may not be doable, may not be appropriate, it may be a third-party application you don't have the source code for. So we can operate at the database layer, but our initial starting point is an API built into the application.
So you have to change the applications.
You have to change the application.
So no more questions. Thank you, Daniel, for your presentation.
Pleasure. And again, if anyone wants to talk about baking or cats or running really slow, they come and see me.